Hey everyone, welcome to Ladboy Coding. Today, we are going to solve problem 39, combination sum. And we can see that lots of companies really like this problem. And this is a really model backtracking problem. So let's see the problem. Given a set of candidates number and a target number, we need to find all unique combination in candidates where the target sum is the target. So for example, if the target is 2, 3, 6, or 7, and the target is a 7, this is the solution because 7 is a 7 and 2 plus 2 plus 3 is also a 7. And here we can see that for each list in the result, the sum is equals to the target. So how do we do this kind of problem? Well, the key is draw a recursion tree. So we need to draw a recursion tree to keep track of how the program works. And if we draw it, it becomes very easy and straightforward. If we can't draw it, it's very hard, or we can't solve the problem. So how do we draw the recursion tree? First, we need to put something in the root, and we also need to keep in mind what is the ending condition. So where should we stop? And then what is the value in each level in the recursion tree? So these are the 3 key points. So for example, if the candidate is 2 and 3, the target is a 6, the answer should be 2, 2, 2, and 3, 3. So let's see how we draw a recursion tree. First, what we need in the root node, we need an empty list as a state, and we also need to store the candidates' numbers. So, and let's define for each node, we put state and the space. The state is just a list. The space is where we need to do a search. So yeah, this is the root level. Then on the second level, let's retrieve each element in the space and put it in the state. So we can see that we put 2 and 3 here. And then we need to put all the space here, and we need to put 3 here. And then on the next level, we also repeat this process. We retrieve a number 2 to put into this array, and we retrieve a number 3 to put into this array, and then so on and so forth. So where should we store the recursion? I mean, where should we stop the recursion? So for example, when the sum of this array is larger than 6, 2 plus 2 plus 3 is a 7. 7 is larger than 6. Then that means we can stop recursion because any number plus 7 cannot equals to 6 because 7 is bigger than 6. So, and we can see 2 plus 2 plus 2 is 6. And we find this array, so we just put it into the result. and we stop recursion. So yeah, this is the recursion tree. And how should we use our program to model it? Especially in this part, we need to put a part of array in this element. So yeah, let's see the code. Okay, so first, let's sort the candidate. And then, so after we are having a recursion tree, this becomes a depth first search problem, DFS. So how do we do DFS? We can use a stack or a recursion, but I usually prefer the stack because it's easier to visualize. So what do we put into the stack? We need to put an empty list and a candidate list. Then what do we do? While the stack is not empty, we need to get the state and the search space of the current node. If the total sum of this array is equal to the target, what we need to do, we just put it in the result array. If sum is larger than target, then that means we still need to do some work. For example, in this case, the sum is just 2, is far away from the target, 6. So we need to do one more level of work. How do we do it? Pay attention. For index in range, length, space. So for example, here we get number 2 and we get number 3 individually. We put it back to this empty state, and yeah. And what is the next space we need to search on? So yeah, this is how we do a slicing in Python list. Let's see an example to interpret these two lines. Okay, so in Python, if we have an empty list and we have a number 1, we can do this. And then the two lists will be concatenated together. So yeah, let's run it. So yeah, and we can see it is 2, 1. And suppose the index is a 0. We have a list 2, 3. And let's print index, comma. This will give us a part of the list starting from the index to the end of the list. So this gives us index 0, 1, 2. And then if we do index a +1, this will give us index 0, 1. So let's print it. It will, I mean 0, 1, and 1. Yeah, so let's print it. And we can see we just get 3. So that's how we do the program. That's how we use program to model the recursion call. And then we can just return the result. If the sum is larger than target, it will do nothing. So yeah, let's run it. So for example, 2, 3, and 6. Yes, it's correct. And to visualize the report, let's print the stack. And we can see that empty 2, 3, and 2, 2, 2, 3. And then we have this. Let's try this. Yeah, this is a better visualization. So in this level is 2, 2, 3, and 3, 3. And then we have this. After this is done, we will go to this side. So yeah. Let's submit our code. Yeah, it's done. So now let's analyze the time complexity. So how many levels are there? There are n levels. Suppose we have one candidate has a number 1, and target is an arbitrary number. For example, 5. We need to output 1, 1, 1, 1, 1. Then we need to go to the nth level, in this case 5. So yeah. And how many work do we do in each level? So in the root, let's suppose we do 1 work. We will assume that for each node of the tree, we do 1 work. So how many nodes on the first level? 2. And then on the second level, 4. And then on the third level is 3. So in the worst case, okay, so it's equal to 1 plus 2 plus 4 plus 8 is equal to 2 square 0 plus 2 square 1 plus 2 square 2, and it's equal to 2 square n. So in the worst case, this is the time complexity. And what is n? It depends on the number in candidates and how large the target is. So yeah, thank you very much. If my solutions help you, please feel free to subscribe and leave a comment. All the code is in the comment and in the description. Thank you very much. Bye-bye.